So when it comes to sort of my style of presenting, there are two goal slides here and a few slides. If this is one of those things where you're like, not real sure if this is for me or whatever, and you're like, you're watching a new TV series or something, and you're like, do I wait till the 3rd episode, the 5th episode, or do I wait till the whole 1st season? Wait till the 2nd gold slide. For the 2nd gold slide, you're like, nah, I'm out of here. Great. Otherwise, you should know by then if it's for you or not. So another thing is if I say anything that is factually wrong up here, feel free to interrupt me. I've been known to do that. I try not to. But if I do, feel free to stop me and be like, hey, no, that's wrong, because I prefer correct information to lack of interruptions. I'm also not ashamed to just boringly read slide notes and then elaborate on it. So there's a good chance I'll do that at some point. So anyhow, here are some of the things I'm going to cover and not cover within this. I like to lay that out ahead of time, so I'm going to cover passwords versus keys a little bit, different key types, different types of multi-factor authentication or two-factor authentication, as well as a couple other sort of minor hardening tricks that you can do with SSH. Some things not covered are GPG or open PGP keys. I'm not going to talk about anything once you're into the box, like audit D, sudo permissions, SE Linux, yada, yada, yada. Also, if at the end there's a link to my slides and whatnot, the slide notes have basically all the URLs that I learned from all the tutorials to do this stuff. And that's one note, is that all this stuff is stuff that I have done. Now, 95% of it was, hey, look, it works. All right, done. And then move on to the next thing, right? Because I'm lazy, and that's how lazy people do it. So, FIDO2 YubiKeys. Now, no, you don't necessarily need a YubiKey. Anyone know what this is? Shout it out. Wrong. It's not a YubiKey. I tricked you. No, it's not a nitro key. It is a security key by Yubico. So, okay, no. So important distinguishing factor, though. Half the cost, or less sometimes, depending on what it is. So a security key by Yubico is just the FIDO or FIDO2 bit. It doesn't have OpenPGP. It doesn't have PIV. It doesn't have all the other features that an actual YubiKey branded Yubico product has. It's also distinct from their YubiHSM line, which is a hardware security module. And there might be a talk foreshadowing at a future time by someone that does like a port admin's HSM using a standard YubiKey, or maybe if we can get it down, even one of these. But anyhow, OpenSSH 8.2p1, or if you want resident key support, which these guys do support now, finally, you'll need 8.3 or higher. Notice those are greater than or equal to. Obviously, I use the various software things. I had to add in Homebrew for Mac because Mac sucks. I don't say that lightly, but I also don't give a crap, so whatever. We'll get into a little bit more of why on that here in a few slides. So the goals for this, right? Client-side stuff should be largely cross-platform. I wanted this to be something that the server side, sure, server's going to be Linux. I'm not going to do a talk, not tonight anyway, on how to run an OpenSSH server on Windows. I don't hate life that much yet. So all the server side stuff is going to be Linux, but the client side, I've tested basically everything I talked about in these slides in some fashion or another with Windows and Mac and Linux client side stuff. As you might have noticed on this slide, I'm an Ubuntu guy, so that's pretty much all that I use there. There might have been a Debian thrown in, but anyhow. Practically deployable in some fashion, including at your organization. If you have anywhere from one SSH server to a few thousand SSH servers, there should be something in this talk for you. I want to emphasize this point. Here's the second goals slide. This is not just for home or personal or home lab or home prod or whatever you want to call it. It's not just personal use. There's stuff in here that should be deployable at an organization if you have any SSH stuff there that you're looking to secure. First big thing, key-based authentication. If you're using passwords, you're doing it wrong, mostly. So keys, for those unfamiliar, are basically a password with a crap ton of entropy because you can still copy it, right? And it can be encrypted, so it can sort of be self-encrypted, and then it's weird because you've got symmetric encryption on something that's asymmetric encryption, and you start going down the crypto rabbit hole there. They're more secure than passwords. You can configure stuff client-side or server-side on this. File permissions are a thing. Foreshadowing. File permissions client-side are a thing. If they're not set right, it tells you mean things that start with the F word, and then it doesn't work. The good sides to keys, though, that, like I mentioned, the copy, you can back them up. If you have an actual YubiKey, you can often put them on hardware. What about elliptic curve keys is the question. Yes, they exist. That's about as much as I know at the moment with regard to scope of this presentation. So you can configure, right, server side, and you can pick what keys can and can't be used. Client side, you'll typically use in your home folder the .ssh folder, a config file that just is named config with no extension, and that you can add in aliases and stuff for hosts, including what key to use with what host, and you can force it to use those keys, et cetera, et cetera. TOTP. Anyone here attempt the CTF a couple months ago that I wrote and it was way too hard? I know there are a couple people. Okay, so I'm going to spoil a little bit for you. The first step was base 64. You just had to encode it instead of decode it. It was really, really mean like that. It was camel case instructions. And then the next one, I just made all of the default 1,000 ports in Nmap open to a web server that did nothing. So you had to find the other ports that Nmap doesn't scan by default. Once you got that, the rest of it was actually a bit more of a normal CTF. Anyhow, this is one of the things I used. TOTP, time-based one-time passwords. This is like libpam Google Authenticator or some crap like that. If we make the screen bigger, you might be able to read it. You might not. I don't care. You can look at the slide notes or whatever afterwards. But you can configure the parameters. You can set a time drift, right? You ever had one of those where your phone's maybe not quite lined up with NTP? You can't log into something, and it's like, oh, okay, I got to wait for it to roll over. Or maybe you got to wait till it's almost expired and you're trying to like get the right thing. You could configure that on the server side. You can configure code reuse, which generally you'd want disabled. But for my CTF, I had it enabled because I'm like, I don't care if 5 people use the same code if it works. You can also force or exclude TOTP when using SSH keys. Now, a caveat of this, it will ask for a password. I have not found a way when you're using TOTP that it won't ask for a password. Even if you're using a key, it'll still ask for the user's password. My understanding is this is a limitation of the way that PAM handles this stuff, right? Because it's basically a PAM plugin or extension or whatever you want to call it that does the Google Authenticator side of things. And yes, this really is like ASCII QR code in a terminal, in case you were wondering about that. But you can configure whether like you just can't log in or whether it asks for TOTP with a key and whatnot. There's a fun little setting that's basically if they don't have 2FA set up, don't ask for it. But if they've set it up, force them to use it, which is generally how you'd want to configure this if you're going to do that route. I included these slides mostly for historical reasons. I actually gave a sort of version 1 of this talk at the Linux user group earlier this year. I think it was February. Don't quote me on that, though. The red X is transparent, so if you want these slides afterwards, you're welcome to use them. I have previously recommended this way of doing things for relatively secure and hardened SSH. I no longer recommend it for what's coming up on these next 3 slides, as in my mind, superior to those methods of doing it. Some caveats to this, though. These are not really supported on Chromebooks or smartphones. Also, Mac sucks, so it's not really supported on Mac by default. If you use Homebrew, you can. I was talking with Cooper a bit before this, and it has to do with Apple wanting to use their keychain for everything. And yeah, you can go and actually look at like on Git and see that like they just compiled it with the option disable security keys because they're Apple and they do what they want, I guess. But if you install the Homebrew version of SSH, it works fine. So the advantage here, right, is that now you've got a second factor. You've got the key, which functionally is something you know, right? Maybe you don't know it, but it can be copied as something you know, and therefore it's more or less as something you know. Then you have the something you have, and pretty much any, as far as I know, any proper FIDO key that follows spec, FIDO1 or FIDO2, you can have FIDO-backed keys. Now, there are different key types. There's ECDSA, I believe, and then there's like ED29915 or some crap like that. The 2.9 whatever the crap only works with a handful of things from what I found. But the shorter, simpler to pronounce one that I don't have written down, you can use with pretty much anything. I've pulled random hyperFIDO keys out and they've worked. EC stands for elliptic curve. Okay, great. So EC DSA, and then DSA is what? Data standard algorithm, data security algorithm? Something like that. Who knows? Feel free to Google it, yell it out. I don't care. One of the advantages to this, right, is you get all the advantages of key-based authentication, right? You can encrypt it locally. You can back it up to different hardware, et cetera, et cetera. But the advantage that if the private key gets stolen, it's not the end of the world. I actually I believe in that CTF that I did. I had some private keys that I just put out there. But because I had various ways of 2FA on them, and then I had some restrictions once you got onto the box, you couldn't really do anything. It was doing everything that's wrong the right way, was basically what it was. I did all the things you're not supposed to do. I had publicly accessible SSH. I had SSH with the private keys that I handed out to you. I handed you the 2FA for the private keys. I did all the wrong things. And as far as I know, it still didn't get hacked. Should probably check on that, though. Anyhow, so you can chain it with other requirements, sort of as I've alluded to. You can still do the local SSH config file, yada, yada, yada. Here are some random screenshots of me using that. Windows support is sort of in its infancy. More on that here on the next slide. So FIDO2 discoverable keys, also known as resident keys because we're IT and we can't just pick one term for the same thing, right? So anyhow, the FIDO2 specifically, which are the ones that if you can just plug it in and Microsoft says, oh, we know who you are, have fun, that's FIDO2. For whatever reason, FIDO doesn't support that, and for whatever reason, Microsoft doesn't see it as a second factor. They see it as an only factor. Yay. Anyhow, those types of keys like this one is one of the newer security key by Yubico that is FIDO2 capable. It even has stamped on it, or not stamped, but like silk screened the word FIDO. I don't know why they didn't put FIDO2, but whatever. This is also USB-C variant of it, which is sort of fascinating that they decided to go with this form factor for the USB-C for those, but whatever. It's like 25 bucks. They're an excellent replacement for those open PGP things because much like with those, you can store the keys on this. Now, there are caveats. The more advanced we get, the more caveats we get, right? So there's no client-side or server-side modifications needed if it's supported properly, right? So on Mac, you might need to do that thing just to be able to use them in the first place. On Windows, in GitHub, in their PowerShell, it's actually the PowerShell repo that's 132-OpenSSH. This works. It works out of the box. You just unzip it, get into the directory, and boom, it works. It's amazing. It's beautiful. I can't wait to see that actually be wrapped into Windows proper. Although I kind of doubt that they'll backport that to Windows 10, but on Windows 11 it should be good to go. But on Linux clients, I've yet to come across a standard popular Linux client that didn't just work with this. It doesn't require a YubiKey, right? Any of those FIDO keys that support the FIDO2, the resident key, which so far YubiKey is the only, or Yubico is the only brand I know of that makes them that do support that. But in theory, it's open to anyone that wants to. The key stub is not needed with the, let's see, on-disk key stub not needed like with the non-discoverable, right? Okay, so what that means is that when you have the non-discoverable, and you've just got just a standard FIDO-backed SSH key, you still need the key file, right? You need that key file on disk. That's one of your factors. Your physical hardware is your other factor, yada, yada. With the discoverable keys, since it's all here, you don't need anything on disk. There are basically two ways that you can get the key off of this. And by default, it requires the PIN. More on that on the next slide. But the SSH add command, if you do TAC capital K, or dash, if you're one of those people that says dash instead of TAC, same thing. Anyhow, that will put it into memory, and you use it from there. There's nothing written to disk for that as far as I know. However, if you want to actually extract the private key file and have something on disk, then you use SSH keygen, TAC K, capital K, and it will do the same thing. Works with all the SSH tools, right? SCP, rsync, SFTP, et cetera, et cetera. If it uses SSH as its backend, it should support this. And of course, the big advantage are cheaper than the OpenPGP keys. A little bit more caveats, right? So user presence or verification, as it's sometimes called, those options bring all the caveats. That could be its whole own talk. So I'm not going to get into all that. I'm just going to touch on a couple little things here. So the documentation for this is absolutely trash from what I've found. In reading through it, they use so many double and triple and quadruple negatives that it can be quite a pain to read through, as those of you that have seen me ranting in the SecDSM Discord might be able to attest to. Speaking of which, attest, that's another term they use that could just be another word, but they don't. Anyhow, the big thing to note is that the password protection lives with the stub. If you decide to download the stub, as I'm calling it. Stub's probably the wrong word, right? But if you download the private key, if you use SSH keygen, capital K, it'll ask you for a password because it's pulling it out and it's in clear text right now, right? Like it would be in memory. It wants to know, hey, do you want this file on disk encrypted like a normal SSH key you probably want encrypted? If so, type a password. So when you make the key on these, you can have whatever password you want. It doesn't matter. And then every computer that you go and put your stub, as I'm calling it on, you could have a different password for each of those if you want. It's not like a standard SSH key where you're just limited to the one password and then copy it along, which I thought was pretty cool. You'll want to name each key, because otherwise you don't really have a good way to reference them in some of the SSH commands. The capital O, when you're doing a normal SSH keygen, you can specify you want it to be a resident key, and then the capital O, the O's for options. Application equals SSH colon, and then whatever name you want. Why that syntax? I don't know. The developers must hate us. That's all I can think of. But using the defaults, right? Because you can specify all like, oh, you have to use the button. No, you can't use the button. Oh, you can override if you can use the button, yada, yada, yada. The defaults seem to work just fine in my testing. If you don't press the button, it doesn't go. If you do press the button, it does go. Remember what I said at the beginning? Tested it. It works. Great. Done. So this is my current recommendation. If you are looking for a hardware-backed key to use with SSH, I recommend FIDO2 discoverable / resident keys. From my understanding, they have yet to fall victim to any of the sort of security issues that maybe have come across other key types, and they are more well supported than OpenPGP for a lot of things, especially when it comes to client-side modifications. One of the big things that I would run into with the OpenPGP stuff was that you have to swap out SSH agent for GPG agent, and then it ignores things like your SSH config file, and it breaks your world. And then you spend 7 hours across 5 days troubleshooting something because you forgot you modified your system 3 years ago to use OpenPGP keys for another SecDSM talk. So anyhow, this is my current recommendation, and it's a balance of usability and security, right? Because something can be as secure as you want, and if it's too difficult to use, it doesn't do anyone any good. All right, all that stuff may be a little difficult to deploy in an organization, right? You've got physical hardware keys you have to hand out. You have to figure out how you're going to provision them, yada, yada, yada. Foreshadowing. So then we come into certificates, right? Certificates. If you have a fleet of machines, if you have things that are automated, set up, tear down, Docker, VMs, GitLab runners, that sort of stuff, use certificates. That's the way to do it. So we've got 2 slides on this. So we got users and hosts, right? So hosts are the machines themselves, right? When you first connect to an SSH machine, what does it say? It goes, oh, we have a new key. You've never seen this machine before. Are you sure? This might be a bad idea. This could do some bad stuff to you. Are you sure? And I think a lot of visuals go, yeah, sure, why not? We're forgetting that, you know, the SSL banner warnings that are like, hey, this cert's self-signed. You shouldn't trust it. That's the same warning. If we're going to tell everyone not to do it with web certs, why are we telling people to do it with SSH? That's dumb. Host certificates fix that. So basically, the way this works is you either do it right or you do it wrong, or you do it 7 different ways of wrong. And even when you do it right, it's still wrong. But it's still better than manual key distribution. So if you already have a CA, right, if you've got an AD environment, and you've got a CA or an ICA or something, just use that. Just use that. Don't fiddle with trying to force it into Linux and whatnot. If you've already got cert infrastructure, then lifecycle management and all that, use that. It's there. That's why it's compatible with that stuff. If you don't, and you're setting this up one time on a home lab to give a talk at SecDSM, there's a sort of cheater way you can do. What you do, you generate a key pair, and you say, you are the cert. How do you do that? You just make it up. You just be like, yeah, that's my cert now. And then you use that key to sign other key pairs. And by nature of signing them, hey, guess what? Now it's a cert. So then what happens is those signed certs, it generates these public keys. So you effectively then have 3 keys that your host will need. You have your private key, your public key, and your public key that's been signed by the certificate, or the cert authority, technically, right? Those aren't the cert, those are cert authority. They're issuing you the certificate. So let's see. Here's the part read from slide to make sure I'm not missing anything. Yeah, I mentioned the GitLab runners. Oh, Kubernetes, Podman, any containers. Just take that as any containers. Anything that installs via Pixie or BootP could be helpful for that sort of stuff. Configuring it depends on sort of your flavor of Linux and what versions of SSH you have installed and all that fun stuff. I think I went through about 3.5 documents before I got my first working host config. And remember that foreshadowing about file permissions? Yeah, that comes into play here too. SSH really, really doesn't like it if things are too readable and they're supposed to be more private than that. So yeah, so all I really did for sort of demoing this was I just had a key pair and I named it CA. So I had CA and CA.pub. And that was my certificate authority that signed the host cert. And then the server-side config for the host, I said, hey, instead of using what you think you want to use for your host key, go use this file instead. And it did. And then when I connected, I didn't get the tofu. No tofu. Now, I like eating tofu, but I don't like trust on first use. So to eliminate that trust on first use, it was just trusted because I told it was. Just like, you know, when you put any other root cert into an endpoint and it trusts everything that one signs. The way you do this is typically if you want to do it per client, like on Windows especially, I noted here, because it took me a while to figure that one out. It's in your known hosts file. Just use @cert-authority, and then the public key, you know, your SSH, RSA, blah, AAA, blah, 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 blah. Also on Windows, you can, no, that was the same note, one moment. Undocumented, at least I couldn't find the documentation for it. But by using TACV or TACVV or TACVVV, right, you can get all those extra verbosities for debugging stuff. There's a system-wide Windows file, too. It's at C program data SSH _known _hosts. Why one is known host and the other is SSH known host? I don't know. Apparently, that's the thing. But anyhow, you can also do, again, you can do this system-wide or per user Windows, Mac, and Linux. Mac. Oh, man. Remember how I said Mac sucks? Yeah, there's another caveat here about that one, too. So after fiddling all night, yeah, check your permissions again. Turns out that wasn't the issue this time, thank goodness. Also check for copy and paste errors, like an unintentional new line in the middle of your SSH key string. Because apparently, in Mac, nano is not nano, it's pico. And when you paste in something that's too long and you save it, it hopefully adds a new line where the space was, which breaks the key. Once I found that, cussed a fair bit, got back to work, it worked just fine. Yes, it probably works fine in Vim, but again, Mac sucks. That's all I have to say. So anyhow, user certificates, right? Everything I said about the CA and signing it, and that's all it is, all that still applies. Now, if you're following best practices, you have or at least if you're following best practices the wrong way, so if you're doing it like me and you just have key pairs sitting around that are your CAs, you want a CA for your host signing stuff and a CA for your user signing stuff. If you've got like a real CA setup of any sort, you probably know more about this than I do. Just quick show of hands. How many people have done like actual cert management in an organization? Okay, so probably about half the room. You can ignore most of what I'm saying about how to sign keys because you know that part already.
Really important caveat. You cannot use intermediaries for this.
Oh. Okay, fun caveat and a factual correction about what I said earlier. You can't use ICAs or intermediate CAs. You have to use the root, apparently, which makes it a little bit more sucky, but hey, you want it secure, do you not, I guess. But anyhow, I just used a set of files sitting around, 2 sets of files, right? One for hosts, one for users. All you really need to do is put the CA pub key in your authorized keys, and then any user's key that's been signed just, boom, has access to whatever user has that in their authorized keys. You can also apply it system-wide. I didn't make a note on how, but I have about 9 to 12 different URLs here with various setup guides. So again, if that's something you want, there's stuff afterwards. And you can see maybe some of the configs here on the screenshots. Again, no, there are those 3 key files that matters. There's your private, your public, and your public cert. All right, past the 2-factor and, or at least that style of 2-factor, past the hardware keys and the certs, which is sort of the meat of the talk. Now we're wrapping up, okay, what if I don't want to do those 2, or if I've already implemented those, how can I make it even better? Host access lists, allow or deny. Very simple. In etc hosts.allow, and guess what? etc hosts.deny. You can input specific IPv4 or 6 addresses or ranges, which is fun. You can input host or domain names. And slight caveat here, I've run into some things where if you put in a host name as a deny, but the reverse DNS doesn't have that host name, it doesn't realize that it's supposed to deny that host. So there are a couple little caveats there, right? But test it out. Test it out from places it's supposed to be able to work and places it's not. Make sure it does what you want. Example configuration for like only allow these would be in your etc host.deny. You do an SSHD : all in all caps. And then in your allow, you just do SSHD : and then whatever your thing is. Right here I did 192.168.0.0/24. So typical home network setup, allow anything from there, deny everything else. It appears to just kind of drop traffic / ignore you if you're not allowed. It doesn't give you any fancy like banner warnings saying don't do this. So there's no real screenshot. It's just like a screenshot of nothing happening. So that's why there's not one here. You can also do per pub key or public key host name matching in SSH authorized keys. You know that was the thing? So if you have a machine, say your nightly backup that's off-site that uses rsync over SSH like it's supposed to, like a normal human being, and you only, say you're worried about that key pair getting stolen, well, now you can restrict it to a host name and say, not only is this key required in this authorized key file, but we're restricting it if it's from this host name. So you can combine a lot of these things and get some fun things like that. Fail to ban. This is the one that I have like no slide notes on because I've dealt with it a very, very long time ago and pretty much stopped using it. I stopped using this when I switched to keys. Fun little story time. I had an SSH system that applied some of the things I've mentioned here, but allowed password authentication in some cases. Eventually, my notifications, because I had notifications on it, wasn't that dumb, I started seeing weird usernames. I'm like, that's weird. I wonder what's going on there. Is someone trying to get in? I ran it on a non-standard port. Took like almost a decade before anyone found it. And then when they did, there were these weird usernames. I'm like, what is going on? I looked up the IPs. The IPs were all either Russia or China. And then I got looking at what the usernames were. They were like $ open parenthesis bin bash. Probably not the usernames I want logging in. So yeah, I went to key-based authentication. No passwords for me. But fail to ban basically stopped them, right? They kind of figured out that I was using fail to ban, and what they do is they do 2 attempts from each IP address, and then they jump so it never hit the 3 limit that I had per IP, which I thought was pretty impressive. And I'm like, well played, bye-bye. So yeah, fail to ban could be its whole own talk on its own. It has jails, filters, paths, and actions are some of the terms. What all those mean, I don't know. Look it up, something to know. Like I said, some actionable data, but you're gonna have to figure out in your specific implementation. Again, not demoed or screenshotted, although I probably should have thought to pull one of those fun little usernames in. Now, the ultimate combination of 6-factor authentication SSH. with a big asterisk, because if you know about factors, it's technically not, right? Because number one, trusted IP address, that's someplace you are. Kinda. I mean, you could forge it, right? You could jump box it, you could something like that, but it's more or less it's someplace you are. Now, technically, number 2, number 3, and number 5 are all something you know, because they can be copied as something you know, right? They can be copied like a file. So number 2, software private key, so the key file on disk, right, that you need to have certain permissions on. Number 3, a password to decrypt that private key, which, again, something that could be copied or shared. And then number 5, the password for the remote user, which, again, being just a password, relatively easy to copy and share. Number 4 and number 6 both fall into the category of something you have, right? And I know that TOTP, if it's a soft code, technically you could argue it's something you know, yada, yada, pedantic stuff here. Anyhow, 4 being a hardware device, right? You can't forge these, but it's still something you have. And TOTP, in theory, done right, and not backed up anywhere, the notes or whatever you call seed, that's also something you have. But you can do all of these. I actually have done this before. You can have all 6 of these be requirements before logging into a box. And then if you want to be really mean to whoever you've given this access to, you can just have it run the exit command, and that's the only thing they're allowed to run, and then it'll pop you out. But yeah, so it depends on how you count. Probably overkill. But the point being, you can combine these in all manner of ways that are good and bad. Command restrictions. If you get this far in my mini CTF, if it's still out there, or if you would have got that far, you would have run into this. A lot of the SSH things, you would just connect to it, and it would disconnect you. But it did something. Usually, in that case, it was an echo. It would just echo a string, right? It would print something out to the screen. There's this fun little tool. I don't know if it exists on the Red Hat side, but on the Debian side it does. As best as I can tell, this was developed sort of by Debian for Debian. It's called restricted SSH commands. Now, caveat being that if you use the built-in SSH command restriction, again, that's all it does. You SSH in, it runs the command, and it kicks you out. With restricted SSH commands, it lets you run any commands that you've said can be allowed, and you can do regex or regex or however you want to pronounce that word. So if you're okay with just saying, really, I just need them to like get the time of day on the server because it has weird clock drift, then that's probably all you need. You only need the built-in. But if you say, no, I actually want them to be able to like list files in this directory every so often, or list files in these 5 directories, or make a nightly backup and yada yada, but I don't want them to like have unfettered access and start running Nmap and installing packages on it, then you can install the restricted SSH commands package, make that your restricted command, and then in its config file, you can configure all the commands and stuff that you actually want to allow. And because this, I don't know if you can do it per host, but I know you can do it per user. So again, if you know management users versus automated users, et cetera, et cetera. Now we're really getting into the weeds. We'll come back out of the weeds, though. Don't worry. Cryptographic algorithm restrictions. I believe that's the right term here. You can basically specify what key types and what algorithms those keys use and yada, yada, what's allowed to connect to your system and what's not. Now, for most people, the defaults are probably fine. But if you care about this stuff, or say maybe you only want to allow some random obsolete cipher for some sort of CTF, that could be a thing you do here. You can specify the ciphers. It's the ciphers directive, I believe is what they call those. It's the ciphers doohickey at the left in your SSH config file. You can also check it with Nmap. As best as I can tell, it's just built in. It's tac script and then SSH2 enum algos, right, for enumerate the algorithms. And then you've got to tack on the SV and tell it, whatever port you want, and it will list it. It'll list them out. And you can see in these 2 different screenshots, they're different. So I ran that nmap command between changing things. Okay, I'm told there's also a tool called SSH Audit that can do the same thing for you. FIPS 140, if you know that term, yeah, go look up this slide and look up SSH Audit. I know nothing about that. Crypto policies being the other one. Oh man, see this. That's why I say for me this is in the weeds and over my head. Like again, remember, tried it. Hey, it worked. Done. So that's the extent of my knowledge on this. I made a config change. I told systemd to restart the server. I ran nmap. Hey, look, it changed. Let's put it back. Put it back. Same task. There you go. Logon limits. This is a fun one. So let's say I wanted to let the Russian hackers continue hitting my box, but I didn't want more than one of them to be in at a time. Logon limits, right? So it's really easy. It's in the SSH Security limits.conf file. This isn't strictly SSH, but because in most cases I feel like SSH is where it's most relevant, I decided to include it here. And this is the one of the couple things here that really maybe could be in a separate presentation that's more on general system hardening, but I decided to include here anyway. So you can limit them per user group or the whole system. You can set hard or soft limits. And interestingly, you do get in far enough that you can see the logon banner, but you're otherwise kicked right back out. So if the limit's been hit, even if it's a hard limit, this is basically what you get. You say, there are too many logons, bye-bye, and then it kicks you out. Email notifications. This is a fun thing. Remember I mentioned notifications of those Russian hacker people? Yeah, I get emails for that, which is a great thing. It can be great and it can be terrible. If you're running a corporate system that gets hundreds or thousands of SSH logins a day, maybe don't use email notifications. If it's a home system that should get less than 10 a day or maybe a couple a week, why not, right? So you can email on password fails or any successes. I've yet to figure out how to get it to email when a public key authentication fails. It seems to be where in the PAM chain stuff happens. I'm sure there's a way to do it. It looked like people online have figured it out. I have not figured it out. But on password fail, you can do that. You can even include the password if you really wanted to. And on any success. They're in different spots though in PAM. You want to know more about that? Come bug me afterwards. I've got stuff out on GitHub and stuff we can look at. Several like stock PAM variables can be included. The service, the type, the local user, the remote host, the remote user. As I mentioned, there are some ways to do passwords in there. This heavily redacted screenshot is actually one that was a login that I just had to pull out for a screenshot. That you basically can't see any of the sensitive details. You can just see my Gmail tags on there, and that's about it. So, real basic. That actually uses Swax in the email, but you can do that however you want, right? Because basically, it's just when PAM runs and does the thing, trigger an action. So you could have it write to a log file. You could have it notify a SIM. You could have it do all these things. You could have it send an email. You can have it trigger an SMS. There's a thing I came across recently, a YouTuber going on about an open source Dockerized like push notifications for your phone thing that was real cool. Might transition to that at some point. For now, it's just email. Anyhow, some final ideas, right? I've kind of alluded to this or called it out more specifically. Combine some of these ideas, especially if you're using any programs that use SSH as their secure transport mechanism, right? If you've got SFTP, which I hope you don't because SFTP sucks, but if you do and you have to use it, you might as well secure it, right? rsync, I mentioned, I use rsync for my nightly backup. It's over SSH. Another thing is that you can have different policies and postures for automated users versus interactive users, right? I mentioned these might be really great for when people are doing interactive stuff, but if you've got an automated system, you probably don't want to rig something up to have to tap the button every time it needs to log in. But you might not want to assert that an end user can copy for the users. So you can do different things. I strongly recommend if you don't already own any sort of FIDO key, buy a cheap one. I don't care the brand. As long as it physically functions, you can start playing with it if you care about this sort of stuff. I'd also like to see people expand into various possibilities that I have not discussed here because I had to limit myself somehow. So BSD systems. I assume all this works similarly to that, but given how much Mac sucks, I had to throw one more into those. Who knows, right? It's Unixy and it should, right? OpenSSH server is made by the BSD crew, so like it should work, but I have not tested it. Also, WSL2 keeps getting better and better. I know, Windows stuff, ooh, boo, whatever. But anyhow, it keeps getting better. The firewall rules keep getting easier. The USB support keeps getting a little bit better. I'd love to see it if someone could make like an easily replicatable way, or replicable, whatever word you'd use there, way of doing that with WSL2, right? Make WSL2 the server. It does work with certs in WSL2 as the client. I did test that. FIDO allegedly might work with USB if you do their weird over IP thing, but I didn't do that because out of scope. Feel free to make a follow-up to this, sort of a follow-up talk or a next steps or anything like that, right? Again, I mentioned each of these slides could probably be their whole own talk, at least as long as this one. But I'd love to see if anyone else wants to dive deeper into any of these subjects and come up with more stuff. So that's all I got. This QR code, if I've done it right, should take you to this link, which takes you to this presentation with all the speaker notes and everything else there. Any questions? Is the QR code malware? I hope not. If it is, let me know and I will change it. Other questions? Nobody? Going once? Going twice? All right, sounds good to me. I'll turn over to the board, whoever's up next.